Welcome. My name is Stuart Berkowitz from Out of the Fog Research. Thank you for the opportunity to tell you about our technology. This is SBIR Phase 2, sponsored by NAVWAR. Shipboard signal intelligence missions and communications requires acquisition and direction finding of signals of interest at or near the noise floor. These missions are performed in a harsh EMI environment and over a broad aperture. Therefore, extreme interference mitigation with low loss and high selectivity at the same time is needed, and we have a family of technologies that can solve this problem. Not only the Navy needs this equipment, but also the Air Force and other government agencies have tested this technology on a variety of platforms. We not only do technology development, we also focus on transition, and we've successfully transitioned 2 SBIR Phase 3 production contracts in a variety of applications. We also take things from the very basic level and put together a minimum viable prototype so that we can test as soon as possible in a relevant environment. For example, we took tunable technology and put it on the USS Cape St. George. Baseline current technology doesn't have sufficient EMI mitigation technology to enhance the signal of interest detection. Most systems, particularly SIGINT systems, have problems with their own Navy communications and radar systems interfering with their ability to listen. For example, Navy programs of record that require EMI mitigation to allow the detection of weak signals of interest include PMW 170, for which we're focused on this project, as well as PMW 120, which we've transitioned other technology into. Most other interference cancellation techniques work in the digital domain. The problem with doing it in the digital domain is that you've already gone through all the nonlinear components and so generated a bunch of intermods which result in spurious signals. Our technology is actually interference cancellation in the analog domain, so we can remove EMI that overlaps with the signal of interest, unlike tunable filters, and yet not generate a whole bunch of nonlinear components. This slide shows actual measured data. We're showing a wideband interferer, which is actually overlapping with the signal of interest. In fact, on the left-hand side, you can see that the signal of interest is buried inside that signal and cannot be detected. If you look on the right-hand side, once we've turned on our system and we cancel that interference, you can very clearly see the signal of interest rising in the middle of that signal, and it could easily be detected. We have a whole family of technologies for interference mitigation. We bring things from TRL level 4 to TRL level 9 on a regular basis. We've had multiple transitions, as well as continuing to develop new technology. For example, the CRES technology at various frequency bands is in the TRL level 4 to TRL level 6 range. This is an example of us transitioning technology. This system goes into onto Navy surface ships. We widen the frequency range, improve the noise figure, improve the power handling, improve the spectrum utility, integrated couplers and filtering with both automatic and manual attenuation modes. And we've delivered multiple of these systems that have been now operating for 5+ years. Turning our attention to lower TRL level efforts, we were actually able to do a tunable notch demonstration that was performed on the USS Cape St. George under a prior SBIR. Operationally, it was demonstrated to increase the SOI collection. These filters had a Q that was 10 times better than conventional tunable notch filters. As well, we demonstrated very fast tuning speeds that met the project's objectives. This current project has received Phase 2 funding under NAVWAR for transition into PMW 170. The milestones, the first milestone which we've met was to demonstrate that we could operate over an octave band in the HF. That was demonstrated by a laboratory demo, which is now being put into a prototype box that will be delivered to the Navy for further evaluation by the summer. After that, we'll then focus on a full HF band version, which we hope to deliver by June of 2027. We're looking for additional implementation partners, for example, additional SysComs in the Navy, the Air Force, and the Army. Any DoD RF component, receiver, and systems contractors. We'd like to work on integrating our technology into their systems. A little bit about our company. The company was founded in 2004, so we're a bit over 20 years, focusing on RF products enabled by cryogenic technology and superconductivity for military and intelligence end use customers. We do room temperature technology as well. It was founded by myself, Stuart Berkowitz. We've done work with the Navy, Air Force, DARPA, and NIST. We have a 6 to 8 person staff, depending upon the year, which is proficient in all areas of RF design and implementation. We focus primarily on the analog domain. Finally, this is my contact information. If you want to reach out and find out more about our company or technology, please visit the booth if you get a chance, and thank you for your time.